Recall that if something is linear, first of all, its graph is a line. And that's really easy to remember because if you look at the word linear, you see the word line in there as well. Second of all, you need to remember that its equation is going to be in the form of y equals mx plus b. Notice that y doesn't have an exponent, neither does x. It's just y and just x. Also recall that lines can be vertical or horizontal as well. So looking at this data table, I'm telling you it represents a line. So if it represents a line, then we need to figure out what its pattern is so we can finish the pattern. So notice your x's over here are going up by 2 every time. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. On the right-hand side, negative 3 to 1 is an increase of 4. 1 to 5 is also an increase of 4. So to find the next number in our set, we would have to go up by 4. Well, 5 plus 4 is going to give me 9. And then to find the next number in our set, again, we'd go up by 4, and 9 plus 4 is going to give me 13. So to check if something's linear, suppose you were given a table and wanted to know if it was linear, you would find this increase. You would figure out, is it consistent over here? Is it a constant or a consistent increase or decrease on both sides? That's how you determine if something is linear or not, and how you finish the pattern. So looking at this equation, we can see that it's linear because it just has y and it just has x. So it's important to remember that our x is our independent because it is in the equation, and that makes y out here our dependent. And we could say is a function of x, or we could say that y depends on x. Both of these two statements mean the same thing. As we find our domain and range, don't forget Delore, the robot. So the Delore stands for our domain. We read it from left to right. And our range, we read from bottom to top. You will see Delore a lot, so make sure you become friends with him. So we need to find the domain of this and the range of this particular line or linear function that we have here. So our domain, remember, is read from left to right, so we're going to draw a line through the left side of our graph and the right side of our graph and see where it crosses the x-axis. On the left side here, it goes through -4. On the right side, at +5. It is our domain, so we put x in the middle. At -4, notice there's an open circle, so we're going to put a less than. At +5, the circle is closed, so we're going to put a less than or equal to. Now we're going to find our range. Our range we read from bottom to top. So we're going to do the same thing, just at the bottom and the top. The bottom of our graph is at -2. The top of our graph up here is at +7. This is our range, so we put y in the middle. At -2 at this line, our circle is solid, it is filled in, so it's a less than or equal to. At 7, our graph is open, so we're just going to put a less than. And we're going to find the domain and the range of this parabola. So our domain would be the left and the right of our graph. Well, notice as I follow this graph to the left here, as I'm following it to the left, I hit these arrows, which tell me it's just going to keep getting wider and wider and wider. There is no stopping point. The same thing is true with the right of the graph. If I keep following it, it's just going to keep getting wider and wider and wider. So my domain is going to be all real numbers. For my range, I'm looking for the bottom and the top. Well, I can find a bottom, that's here, but if I try to find a top, it doesn't exist because the top of my graph is up here and it just is going up. That's what these arrows mean. It's going up and up and up, and it's never going to stop. So we'll write this a little bit different. We're going to have just y and just our bottom number, which is this point here is at -3. And we've got to figure out our y's greater than negative 3 or our y's less than negative 3? Well, notice if we look at this line, the graph is above this line, so that tells us that our range is our y's that are greater than or equal to negative 3, because there is a point at negative 3. It is not an open circle.